Okay, hey people, continuing along with our Module 5 material. So I'm going to do a review lecture on vectors so that we can appreciate the next portion, which is getting into orbital angular momentum. So for now, let's talk about some basic information about vectors. Okay, so vectors have both magnitude and direction. Their direction is indicated by the unit vectors I, J, K, corresponding to X, Y, and Z, and the lengths of those vectors are given by their scalars, in this case Vx, Vy, Vz. So overall then we can express a vector as the following: Vxi plus Vyj plus Vzk. And the values of the scalars will determine the overall length and the direction, and the signs of the unit vectors I, J, K will tell us if it's going into the positive x direction or negative x direction, positive y, negative y, or positive z, negative z. So the overall magnitude of a vector is given by the following: square root of the sum of the square of their scalars. So for example, this magnitude would tell us how long this vector is, and the unit vectors I, J, K tell us where it's pointing. So the way that we do vector addition and subtraction is pretty straightforward. So if we have two vectors indicated by V and U, and I'll draw those with two different colors here. So suppose I have vector V and I have, let's see, vector U, for example. So I can add or subtract those, and the result will look something like this in this case. Okay, right? So that would be my vector V plus vector U. And you can see in the addition or subtraction, we just do that operation on their scalars. So Vx plus or minus Ux, etc., and so forth. Okay. So the way that we do multiplication is the following. So we have the dot product, which is a scalar result, and that gives us the overall magnitude of the vector. So you can see here we're taking advantage of the law of cosines. More important to us in this class is going to be the cross product, which is a vector result. So for example, the two pictures you can see right here, if we take U cross V, we get vector W. And now notice the order in which we do that is important. So for example, if we go V cross U, we get a different vector. It will have the same magnitude, but its direction will be different depending on the order in which we take the cross product. So I want to go through that. It's going to be important that we know how to take that cross product. So let's make sure we review that. And remember, it is order specific. So V cross U will go as the following, with the V's above the U's in the matrix. So we're first going to start with unit vector I. And when I start with unit vector I here, I'm going to make a diagonal and go to Vy. So let's write that down. We'll say Vy, and it's going to be Vy times Uz. And now that's going to be minus Vz times Uy. And I'll put that in parentheses, and that's all multiplied by unit vector I. Okay. So I'm going to erase all of this stuff so I can start again, and so that it's not confusing for us. So now we're ready for unit vector J. And so we put a subtraction there. And now unit vector J, we're going to start at Vx. and that's going to be Vx multiplied by UZ, and then now minus VZ multiplied by UX. VZ and UX. I should have picked different letters so they weren't so easy to mix up. And that's multiplied by unit vector J. And then finally for unit vector K, we add that one. And so I'm going to get rid of these now. And now unit vector K, we're going to start here. And for unit vector K, I'm going to travel all the way over to Vx. And now that's going to be Vx multiplied by Uy minus Vy multiplied by Ux. And that's all times unit vector K. Okay, so let's just double check that I did this right. We've got I, which is going to go Vy times Uz minus Vz times Uy. Okay, great. So the i's go over to this quadrant. The j's are going to split the two quadrants. So j will be Vx times Uz minus Vz times Ux. Aha, I knew I was going to make a mistake in there somewhere. Maybe you caught that one already. Okay. And then now finally, unit vector K goes over to the left-hand side of this matrix. So that's going to be Vx minus Uy, or Vx times Uy minus Vy times Ux. Okay, brilliant. So we are going to apply that to our content in the next video.